Hi, welcome to this edition of TMC Newsroom on the Road. I'm here in Dallas, Texas, talking now with Joe Jackson from Archangel Technologies. Joe, welcome. Thanks for joining me.
Thank you. Glad to be here.
So we spoke on the phone not too long ago, and what you guys have really developed is a unique technology, a unique product for the energy space, something in my humble opinion that's really needed. Tell me a little bit about the energy harvester.
Well, the energy harvester is a culmination of about 4.5 years of R&D now. That we're in the process of taking the product to market. Simply put, the energy harvester is a controller that's designed to reside on the customer side of the power meter and complements what the grid utility companies now have migrated to with the implementation of the smart meter technologies. You're seeing, first the trend away from the analog meters over to the digital meters. The digital meters now reporting back in 15-minute intervals versus once a month on the consumption habits of the consumer. The implementation of the smart meters now allows the utility companies to migrate to what's called time of use rating.
Right.
Time of use rating, simply put, is there's a surcharge applied to consumption during peak demand periods, a much lower rate typically on the 24-hour clock for off-peak, typically in the middle of the night. The harvester's job is simply put to capture energy in off-peak periods, take that energy and store it locally there at the consumer's prim, and then make that energy available the following business day. So when the rates go up and the demand on the grid begins to peak, the amount of energy at the consumer level is clamped down on the grid side of the connection, and we replace that with stored energy that was taken previously the night before, typically.
So we're looking at sort of a twofold use. One is to on the consumer side, lower the usage of energy during peak periods, and on the utility side, ensure that peak capacity or maximum capacity is not necessarily overcome.
That's right. That's right. So, I mean, there's a wide number of benefits. First, let's look at the grid benefits.
Mm-hmm.
I mean, benefits to the grid. You kind of got to look at, why is there a surcharge for peak delivery? Well, because it's more expensive to deliver, when everybody's running their air conditioners in the middle of July and the amount of generated energy capacity is at its maximum, you begin to see rolling blackouts and things of that nature. Well, what we help to do from a offload standpoint is by taking during the previous 24 hours, during the off-peak generated periods, we take capacity from the grid, store it, and then reduce the amount during peak that is taken from the grid. So it's very beneficial to the grid. The benefit economically to the end user consumer is quite straightforward, and that is that the consumed energy is normalized to the lowest cost denominator. If, say, for example, in a lot of markets today, there's roughly 24 very active, large utility markets, and that rate of adoption is exponentially increasing across the United States. There's approximately 37% of the domestic U.S. today has either been converted to smart metering and time of use, or they're in the process of being converted right now. So there are millions of customers already affected by or have the opportunity to choose to go to time of use rating. So economically, by being able to compress the amount of energy that you buy from the grid down to hours that are purchased off of the grid in the off-peak period, it helps to reduce the check you write at the end of the month for what you consume without changing any of your habits, which is absolutely a key point. I don't have to remember to turn my thermostat down or depend on someone else if I'm a business owner to turn that thermostat down, to turn the lights off, just human habits. We, much like a PBX, sit back in a closet with the lights off. Once the system's installed by a licensed electrician and it's provisioned, it just sits there and does its job, and end user consumer doesn't have to change their habits at all to be able to capture directly very significant benefits in terms of cost savings.
And in addition to that, it serves as something of a backup power supply in the case of a blackout.
Correct. That's absolutely right. So, in the case of a power failure on the grid side, whether that's due to storms or anything else, as soon as the grid supply is not available, then we instantly begin to discharge the stored energy in the battery. So, on the consumer side, things continue to operate. So it's much, and likewise, other things that are undesirable, like for example, in a large data center. Certainly one of the undesirable characteristics of power coming in would be harmonics and noise and spikes and things of that nature, and we filter all of that out both ways. Again, another benefit to the grid is if there's something behaving badly on the inside of my building, that gets filtered before it goes back out to the grid, so it's not causing problems outside of my building as well.
What's the go-to-market strategy for you with the energy harvester?
So the go-to-market strategy is to take the product to market through a 100% distribution reseller channel. The reseller partners that we've identified are regional electrical contractors. It takes a licensed electrical contractor to install it. So that's a very logical, straightforward approach there. Folks that substantially or large HVAC regional contractors. Again, 60% of the check you write month after month is typically for HVAC. So just to put a harvester between, for example, the HVAC load and the supply dramatically can reduce the overall impact on the energy consumed. Then the third, and I think it's important to note that the harvester not only is able to help from a grid standpoint in terms of being able to take stored off-peak energy, but it's also able to take and benefit from renewable sources as well. So concurrently, it has multiple energy inputs. So there's an input for grid incoming energy, obviously. Then there's additional ports for things, one port that's optimized for solar, for example, and for wind. Solar, as an example, is quite literally a plug and play. If you have a solar array on your building, you plug it into the controller, the electrician plugs it into the controller, the software automatically begins to adapt. Once it sees that energy available, it blends that in with the battery stored energy, and ultimately the objective of the software is to minimize the amount of energy that it's taking from the grid. So, in terms of cost, and going back again to your question about distribution, it's a perfect fit for folks that are in the solar business because you look at the cost of or the recovery of the capital cost to implement a solar project. It can be sometimes 6, 7, 8 years. In our case, being able to take the benefit from solar coupled to the time of use rate delta, we recapture our capital cost on the controller. The harvester can typically recover itself ROI-wise in, let's say, for example, 18 months or less. Then it can begin to recapture, if coupled together with a solar project overall, it can begin to recapture a lot of that cost as well. So in a 6 to 8 year typical model, it might compress that model down to maybe 2 to 3 years instead. Yeah.
What kind of capacity does the energy harvester have in terms of, obviously it's going to depend on the size of a home and the types of things that are in the home consuming energy.
Right.
But what kind of capacity are we talking about?
So, great question, by the way. The primary focus for the harvester is small to medium-sized businesses. In the case of, say, for example, you mentioned homes, a larger home, perhaps over 6 to 8 tons of HVAC, for example. The cost begins and the payback begins to be fairly dramatic. From a capacity standpoint, we measure it, kind of think of it like a refrigerator from an analogy standpoint, where you have perhaps a small bar-sized refrigerator right? From an application point of view, doesn't hold a lot, but it holds enough for what you need it for, right? Residential refrigerator, again, a little larger. It serves its purpose, right? In a food service application, I might have a walk-in freezer. So, I've got different sizes for the different needs. And the harvester, from a capacity standpoint, is sized very much the same way. So we look at the application from a consumption standpoint, and on the 24-hour clock, how many hours, contiguous hours on the clock, are those hours that are defined as peak hours. So let's say from 2 p.m. to 7 p.m., 5 contiguous hours. What you would do is have enough stored energy to be able to carry you through when hours shift to peak from off-peak. We're going to have enough stored energy to be able to carry you through those peak hours to be able to bridge that gap. So depending upon the nature of your consumption, it might be as little as a 5 kilowatt system. It could go as large as a 50 kilowatt system. For applications that need more than 50 kilowatts, it's modular, so you can take, for example, if somebody says I have a 100 kilowatt need, I could take two 50s and couple them together.
When is the product going to be ready for market?
So at the present time, we are conducting our live field trials. The field trial objectives are principally focused on things like ease of implementation for our reseller partners, finalization of packaging, aesthetics, and that kind of stuff. The goal right now is to get into general availability and actually begin to provide product to our reseller partners in late Q3, early Q4 of this calendar year.
Excellent. Well, I look forward to hearing more when that does happen. Certainly a very much-needed product for the entire country. To our viewers, thanks for watching this edition of TMC Newsroom on the Road. Joe, thanks so much for joining me.
Thank you. I appreciate it.